Okay, so what you've been waiting for, our HVAC. So we added heating and air, and what I did was I used a function in MATLAB to make a heating and air conditioner based on control laws, basically if-then control structures. So if the temperature wasn't what I wanted it to be, then I turn my heater or air conditioner on. Okay. Okay, and like I said, our assumptions, we didn't really know what it was. Okay, so our assumption was that our heat blows at 91 degrees and our cool blows at 55 degrees. Okay, and we didn't know what our coefficient for our air conditioner is, so we just used 0.5, so because it looked about right. And for our inputs for our HVAC were our time and our internal temperature. So that's how we based my control laws on. Okay. So we had to have a temperature policy, right? You know, how were we going to gauge when we were going to, what's comfortable and what's not? So what we used were the ASHE guidelines, and ASHE stands for the Association for the Advancement of Sustainability in Higher Education. And basically it says during occupied times, which are usually 8 to 5 on weekdays, a comfortable temperature for us human beings is 72. Okay, so during those times, like I said, if the building was at 72, then our air conditioner wasn't blowing. But if it derived, and if it went off that mark at all, then we turned our air conditioner on or our heating. So for the fall, spring, and winter, okay, like I said, for our occupied time it was 72. For our unoccupied time, which was late at night or during the weekends, we put it at 55 degrees, then we kept the heater on. Okay, so because we didn't really account for if it got too high because there's not many 95-degree days in January. For the summer, we did the exact same thing for the occupied time between 8 and 5. We put it at 72, and then for our unoccupied time, we used 85 degrees, and then we cut our cooling down. Now you can see a couple issues that might arise from here because there might be times where if we do it like this, then the air conditioner's going to have to work harder for a longer period of time. So there can be some issues there. Okay? So here are results. Okay, so I want to come back to this second. I want to talk to you about this one first. So here's our inside temperature with our controller. Okay, you kind of see that it tries to stay at 72, and then if it's not, it's either unoccupied or it's working towards getting back to where we want it to be. Okay. Now, this is probably one of the most important things, and if you've been sleeping through my presentations, this is where you want to wake up. Okay. So right here, this is telling you when your air conditioner is on and off. Okay. So with this, you can see when you're using energy and when you're not. So you can say by the hour when I'm using energy, you can kind of see where you can cut things off and things of that nature. And so this is the ultimate thing here. So when you go back home, you can kind of see, okay, when am I using my air conditioner? Maybe I should cut it off. Nobody see it. Okay. All right. So in conclusion, there are a couple, like I said during the presentation, there are some problems with the assumptions. Okay. Again, our model is very simple, so we don't account for, just this room. Okay. There's going to be different properties of heating and cooling. We know that heat rises and cold comes down. Also, we don't know about the insulation. Okay, we don't know how much is going to stay in and how much is going to go out. Okay, so this is very simple. Okay, and now since I'm graduating, Dr. Inspector plans to make this harder, right? And so there's going to be a lot more to be done. So, but a couple of example things to make it a better controller, maybe on the weekend, okay, when it's like really cold. Like I said, during unoccupied times, it lets it get really cold. But maybe a smarter controller will predict previous behaviors and say, okay, well maybe if I stay on a little bit longer now, then I won't have to work as hard during the week. Okay, so so those things will make it a little bit smarter and make it better, and also just there can be a better model for the building with PDs and things of that nature that Dr. Ansberger will continue to work on. Okay. So there are my references. I'd like to thank Dr. John Ansberger for working with me outside with me for this. This is totally independent, and it was just something I really wanted to do. So I appreciate your time and the University of Tennessee for having me here, and thank you very much.
Are there any questions?
You had an HVAC coefficient that you said was, well, you decided to let equal 0.5. Could you like run like a small actual physical experiment in your building to see if you could figure out if that 0.5 is a good coefficient or not?
Oh.
I mean, could you like turn the heat off for an hour and then turn it back on and see how long it takes the furnace to bring you back up? Or, I mean, yeah, how tough would it be to try and get with an experimental value?
Experimental value? Yes, and you're exactly right. We talked about this. Fortunately, I was doing graduate school stuff and class, but yeah, if you, even for the building coefficient, there's different ways where you could experiment and see what exactly that coefficient is. And most of the times, from my understanding, it's not more so guess and check, but it's kind of like you experiment with it and see, okay, well, this you can kind of see the behavior, okay, based on the different coefficients. So you're like, okay, well, this is behavior, maybe this is the behavior, or something like that. So, it would take experimenting. So, but unfortunately, we didn't have time to do that.
I have a comment. I think this might look as a similar project done by a group at Mercer College. Are you aware of that?
Oh, no, ma'am.
I mean, they didn't do exactly the same thing, but it's actually published in the MA journal, and you might look into that, or send me a message if you could look into that, because they were doing the same thing with, building and using that type of station. So, I'm not sure they have the data, like the big private data you have in your thing.
Okay.
Any questions?
Yeah, did you get your school to agree to give you a cut of the savings?
I thought about it, but I don't know.
Here, let's thank the speaker. And the next talk will be at 2:00.